So we're going to test this solution out using a fairly inexpensive CAD program. Let's go back to our example here. And we're going to start by drawing a line from point A to point B and then to point C. So our first spot is going to be 0. Wait a minute, I got to draw a line 0 to somewhere else. But the question is to where. It was to 5 and 3. Five and 3. Okay, we hit enter. Next, I'm going to zoom back out a little bit. Next, I'm going to do a position, just drawing a line from B to location 10 and -1. You can draw a line from the point B to the point 10 and -1, I believe. Yes. Nope. I'm drawing at 15 to the point of 15. Try it again. (15) and -1. Next, the velocity vector is going down at 30 degrees. So I need a line that goes 30 degrees from the horizontal. So there's a variety of ways to make that work. Just draw a line straight out here. And I need it to go 30 degrees. So what I really need to do is do a working plane Okay, I'm going to say, 30 degrees. Okay, click here. Okay, I've done an arc that's 30 degrees. At first I was going to set a working plane and move to it. Well, let me make sure that I've got this correctly. I'm going to look at that looks like it's 30 degrees. So I'll go ahead and drop that out. This means this line right here, do a copy and a paste, it is at 30 degrees. So I'm going to attach it to that point, and I'm going to move these out of the way for the time being, and I may just change their color to red just to keep them out of the way. Next thing I'm going to do is I'm going to do an instant center. So this rod right here is the link BC. I know the velocity is going straight down in that direction, so here's what I'm saying. Yeah, get this one out of the way. It's already defined as my 30 degrees. So there's the velocity vector. From this point up here, I know its velocity vector is perpendicular. So how do you, in other words, this point is pinned. If you want to look at it or draw it, that's not going to work. Here's what we need. Here. So in other words, this is point A. Which is just pinned there. Let's go. I was going to make that arc. Velocity A, non-existent. Meaning that the velocity at point B is perpendicular to the line from B to A. So how do I draw a perpendicular? If I've got good eyesight, I can look in here and find that. It says set point 1 end points of the perpendicular in an existing line. So it really doesn't matter. Just do that. So this line is perpendicular 90 degrees to that line. I could do something like for purposes of draw the vector here that looks like that. Go ahead and move this out of the way, and then put this vector right there. So what we have is point B going this way, point C, which I did not label, right out here. Now what I need to do is I need to draw a perpendicular, and what I'm going to do is zoom way out here. I'm going to draw a perpendicular out here to that line, and I'll move that line back in a second. I'll draw a perpendicular way out here to that line. Now, here's the key. There's where this point crosses the instant center. You got a couple of choices that you can do. One is you can find the intersection of two lines, which is a F4, I believe. Snap to the nearest intersection, snap to the intersection of two specified lines. Maybe just F4. What we'll do, so if I hit the F4, if I get in here and hit F4, that's not really what I wanted to do, but let's do it in reverse. I'm going to draw an arrow to, so that is in fact your instant center of BC. So the next thing to do is come in and do some dimensions. Just a free-form dimensions between a couple points. I'm going to change the color to green just to keep track of things. I'm going to go in here. I'm going to put a dot. Oops, undo it. From that point to this point, 8.57. Go back and put a dimension between this point and that point. .661. So what I'm going to do now, take a full screen snip, go back into here, and finish this problem up to see if I get the same answer. So here's the way I'm going to do it. I'm going to come over here, take an actual scale drawing, drop it in there, and then I'm going to zoom back in on it with the knowledge that that is 50 feet per second. Okay, all right, here we go. So this is a value of 50 feet per second. So now we're looking at V is equal to omega R. That's 50. This is omega BC. The R is 8.576. So now 50 divided by 8.576 is 50 divided by 8.576 becomes 5.832, which is that. Now, the key is it is obvious that the rotation is that way. We set our coordinates up so that this is X, this is Y, this is a positive rotation. So it turns out omega BC in a sort of sense is a negative rotation, and I've already forgot its value, 5.83. if there is this object, which looks like this, it's a rigid triangle, so to speak, that is rotating that way, then the velocity of B is equal to omega BC times R B to the instant center, which is equal to minus 5.83, or you don't really need to put a plus or a minus here because this is related to our assumption. The distance there is 6.66, or the velocity of B becomes 38.82. 38.829. So that's the actual magnitude of the velocity of B. It's going this direction, so then the question is, how far is it from here to here? Because now we're talking about this link has to rotate that way. I'm going to go back and get that from the drawing and put a dimension down there. Should have done that before. .831. So this dimension is 5.831 units. So this means if you're looking at velocity of B is equal to omega AB times R A to B, which this time would be 38 from here, 38.829 times omega AB, which I don't know, times 5.831. So then you just have that number 5.821 if I remembered right, 6.67, which is pretty close to the number we got right here, 6.66706. Let's see, 5.831. Oops. So that's a little closer, 6.66 and then 6.66 there. So I'm just going to take it at that. Omega AB is equal to 6.66. These two, this one and this one, now looking at the picture, this is a positive rotation here. This is a negative rotation because this is a positive rotation. Turns out, using instant centers, I get exactly the same thing here as I do right here and right there. So I'm going to go ahead and pause or stop this video and drop it out there. This was a check to make sure my omegas jived between those two.